Josh got the thumbs down, which means he did something wrong. Look at what Josh did. Josh decided to check Gina's work. So what did Josh do wrong? And this is something that I'll give you a hint. What Josh has done wrong is something that I've actually been hounding him about. Okay? Right? I've been hounding you about just not doing it right. Just get it right already. Because triple would be 15,600. That would be triple. And he's saying that it's really just 15,312. Anybody know what he did wrong? On this question, did you get exactly 18%? No, you did not. You did, maybe when I told you to write down 18. What did Josh use? Exactly 18%. Yeah. That's the error. That's where he got it wrong. Remember, when you round, you're wrong. I mean, once you round, that is the wrong answer. Sometimes we say round. We're going to take the wrong answer just for convenience sake. But she didn't really have an 18% rate. It was really like, what, 18.31020481. That's closer. Even that's not exact, but that's closer. Okay. So, the moment you round, you start having the wrong answer. Okay? Alright. Just an example. Once you round, let's look at, let's leave Gina alone. Let's talk about dead people. Okay. How's that for a transition?
I like it.
Yes. Cracking the cake. So, okay, let me just pause. Alright, a coroner uses a formula derived from Newton's law of cooling, which is a general cooling principle, to calculate the elapsed time since a person has died. This is the formula. This is actually a really easy version of the formula. Okay, T, big T, little t. Alright, big T is the body's temperature in Fahrenheit. R is the constant room temperature, and T is the elapsed time since death in hours. Okay, so at 8:30 a.m., a coroner was called to the home of a person who had died. The constant temperature in the room where the body was found was 70 degrees Fahrenheit. At 9 a.m., the body's temperature was 85.5 degrees Fahrenheit. Use this temperature to estimate the time of death. Alright, so here's what we're going to do. We're going to fill in what we know and solve for what we don't know. What information have they given us? What do we know? Room temperature, where does that go? And for R, so something minus 70 over 98.6 minus 70. Okay? What else do we know? Okay, what else? We know the body's temperature, which is big T. it was 85.5. And that will give us little t. And what does little t stand for? The time that is elapsed since death occurred. Alright, so let's get out our handy calculator. So I've got 85.5 minus 70 divided by. I'm using lots of parentheses because I want all this in the calculator at once. So here's what I have right now. I have negative 10 times the natural log of this answer, which I'm not going to erase this answer from my calculator. I want this to be remembered forever. Well, only since I hit clear. So I'm going to put in negative 10 times the natural log of this answer. Okay. And I get, it's about 6.13. So does that mean this person died at 6:13? So this is how much time has passed, right? Is that 6 hours and 13 minutes? No, it is not. Because how much? What is this? What is this 13? 13 over 100, and how many minutes are in an hour? 60. Okay. So here, if we have to find time of death, we need the TOD. All right. So time of death is going to be 6 hours previous and 13 hundredths of 60 minutes. How am I going to find that? Yeah, or I could just, if it's of, you can just straight multiply. You can do 0.13 times 60. That will tell you how many minutes it is. About 8 minutes. About 8 minutes. So I need to go 6 hours and 8 minutes back. Where am I starting from? When they take the temperature. 9. I'm starting at 9 o'clock. So when did this person die? (2:52 a.m.) TOD 2:52 a.m. Yeah. Okay. Alright, do B. B is the same problem. It's a different time and a different temperature. Alright, so answer B. Alright. So a more accurate estimate of time of death can be done by taking the body's temperature at different times and then averaging what you get. So we did a second temperature reading. At 9:30, it was 82.9 degrees. So let's find that time of death. Tell me what surprised. All right. What's an estimate for this part? Even though I know you didn't really estimate that. What's your estimate for that middle part? Yeah. Okay. And then I do -10 times the natural log of that, and I get about how many hours? I heard 7. That's right. What's the rest of it? Yes, 7.96 hours ago, which would be 7 hours, almost 8. Let's see, 0.96 times 60, 58 minutes. So what's the time of death according to this estimate? It's 9:30 this time. 1:32. What was the last time of death? Exactly. Right. Alright, question C. Compare the estimated time of death from part A and B. Are they fairly close? The first one was what? 2:52 and 1:32. Yeah, those are pretty close. Hour and 20 minutes, yeah. So, what's a more accurate estimate of time of death? If you were to average those two. What was it? I can't remember anymore. 1:32, and what was the other one? 2:52. I wish I did this actual question. 2:52 and 1:32. Can you average that? Can you average time? Like, seriously, can you know how to average time? No. Alright, what's the difference? How much time passed here? It's only two numbers. 80 minutes. What's half of 80? 40. Okay, so what's 40 minutes either way from here? If I add 40 minutes to this or take away 40 minutes from that, that's going to be the time in the middle. What time is that? What? Huh? What? 2:12. Yes. 2:12 in the a.m. I didn't even realize that 2:12 happened twice a day. I always miss that other one. Alright, now let's look at question B. Now we're going to change it up a little bit. Assuming that the body remains in a room with a constant temperature of 70, determine the temperature of the body after 24 hours.
You don't know the temperature of the body.
Alright, so now I know little t. That's 24. I know this, because that's always the same. What's going to go in here now? Big T minus 70. And right here? Okay. Let's start off, let's get rid of that -10. That's going to be T minus 70 and what? 28, 28.6? Okay. Okay. We've got a natural log here with the argument missing. So let's change it to e to the -2.4 equals t minus 70. T minus 70 makes me probably we can shoot off a rocket or something. Alright, you can finish it from there. I'll wait. Go ahead. What steps will you take to solve this? What? Multiply times 28.6. I'm going to do e to the whatever. times 28.6. Then what will I do with that answer? Add 70. Right, okay? When you do all of that, what do you get? 17 point what? 5. What type of five? Okay, I couldn't hear that part. And that's degrees Fahrenheit, right? Alright, so in 24 hours, the body's going to be about 72, about 72 and a half degrees, okay? When will the temperature of the body drop to 60 degrees? Explain your reasoning. Go ahead, work on that one. When is it going to be 60 degrees? Explain your reason. So when will the temperature drop to 60 degrees? When it does? What'd you get for an answer? What? Right. That's right. It's not going to drop to 60 degrees. The room is 70 degrees.
Oh my God.
Think about it. It's gonna require some outside force to get colder than the room. Remember, everything tries to get to the same temperature. You know, remember that from science? Come on, you're taking a science test today. So you remember that, okay? Everything tries to normalize to get to the same temperature. So if it stays in a 70-degree room, it's not going to get to 60. I know, right? They got you on that one. They did. They got you. All right, I need you to solve a murder mystery.
Okay.
So at 6 p.m., a coroner was called to the home of a person who had died. The body was found at the bottom of the stairs, where the constant temperature is 65 degrees Fahrenheit. At 6:30 p.m., the body's measured temperature was 95.9 degrees Fahrenheit, and at 7 p.m., the body's temperature was 93.7 degrees Fahrenheit. A witness claims that the person fell down the stairs around 5:30 p.m. and she immediately called for an ambulance. Is her statement consistent with the forensic evidence? Exactly. Or was it Colonel Mustard? Okay, so you've got two estimates here. It was 93.7, right? Okay, so this was the first one. The 95.9 was the first temperature reading, and this one ended up being about how many minutes? Do I know? 50 minutes. This was about 50 minutes, and this was taken, the first one was taken at 6:30, so that would put this at 5:40 p.m. Okay, this one, did you have time to get to this one? Was about how many minutes? Okay, it's about an hour and 35 minutes. You got 1.58, which is an hour and 35 minutes. What time was that one taken? At 7, so that would be 6 and 5:25. So an average there, that's like what, a 15-minute difference? So that puts it at about 5:32 to 5:33. So yes, I would say yes, that person is most likely telling the truth. Well, it just says they fell. We don't know what made them fall. So, but we know that as far as time goes,
And they were at the bottom of the stairs.
the time happened correctly, okay? All right, look at your score out.